Good morning, everyone. On behalf of the ISO, I'd like to welcome you to today's Greenhouse Gas Coordination Working Group call. My name is Christina Guimera, representing ISO Stakeholder Affairs, and I will be facilitating today's meeting. Today's slide deck presentation is available on the initiative webpage. You can get to that page by going to kaiso.com, and then under the Stay Informed tab, you'll see the Stakeholder Center tab, and then under that, you'll see Policy Initiatives. If you click that link, it'll take you to our main initiative landing page where you can search for the initiative webpage. This meeting is being recorded and the video file will be posted to the initiative webpage for information and convenience purposes only. The recordings and any related transcriptions should not be reprinted without the ISO's permission. If you need any technical assistance at any point during the meeting, please send a chat to Inteller Events, the host. To ask questions during the meeting, you can open the participant and chat panels on the bottom right. You can then raise your hand by selecting the raise hand icon, or if you joined audio only, you can press *3 on your device. And for everyone joining us today, please state your name and affiliation first before speaking. And you can also always send comments and questions via chat to all panelists. Please note that commissioners and advisors from state public utility commissions may be in attendance today. And next, I'll turn it over to Isabella to go over the agenda. You are muted, as Isabella.
Thank you. Good afternoon, everyone. My name is Isabella Nicosia. I am an account manager here with the stakeholder engagement team at the ISO. I'm also the GHG Coordination Working Group facilitator. So for today's working group, we're going to start off with some counterfactual examples led by George Angelides. I'll give a little bit more background on that in just a moment. But following that presentation, we'll go ahead and take a 10-minute break and then come back and shift our focus to the accounting and reporting approach, which was outlined in the issue paper that was recently published. And Anya will be leading that discussion as well. And then we will wrap up today with some next steps and take it from there. So if we can go to the next slide, this diagram just shows where we're currently at in the working group progress. So we're here towards the end of the working group diagram under assessment and resolution, specifically focusing on that accounting and reporting approach and counterfactual examples today. So if we go to the next slide, so George is going to talk about the GHG counterfactual, which helps reduce secondary dispatch, or what we've referred to it as in this working group as leakage as well. So the GHG counterfactual is a key element of the GHG design and an area of the EDAM design that the ISO anticipates will yield significant reduction in secondary dispatch as compared to what occurs today in the WEIM. So in last April's working group meeting, Vistra suggested consideration of an alternative approach to a GHG counterfactual. And then in subsequent working groups, the ISO shared the philosophy of the current and FERC-approved design, as well as alternative approaches to the working group that the working group could consider to the counterfactual called a no GHG cost approach. So in response to requests from examples from WPTF, George is going to talk about the counterfactual and various approaches to it before sharing an example of this no GHG cost counterfactual approach that we had discussed previously. So the goal for this is for it to be an interactive session. So please feel free to raise your hand if you have questions or suggestions. And with that, I'll turn things over to George to kick us off with these examples.
Thank you, Isabella. Good afternoon, everybody. We originally planned this presentation for the December 20th, but we had to move the stakeholder group meeting here today. So some of the material we presented before, and we're going to walk briefly through those to make time for the new element in this presentation, which is the example that we added to illustrate how this alternative greenhouse gas counterfactual will work. So let's get to the next slide. So just as a brief introduction here, as Isabella mentioned, really the objective of the greenhouse gas counterfactual is to reduce the secondary dispatch in our market solution, which I will remind everyone that is based on the concept of a greenhouse gas attribution that is awarded to resources that are external to a greenhouse gas regulation area, and you use that attribution to import, to a net import into that greenhouse gas regulation area. And just a reminder again, what we mean when we refer to a secondary dispatch, it's really the phenomenon where higher emitting resources outside the greenhouse gas regulation area backfill for the greenhouse gas attributions of other resources that are external, which now are attributed to imports into the greenhouse gas regulation area. So there is an emission cost for these resources that do the backfill, but this cost is not captured in the market solution because we only take into consideration the cost associated with the greenhouse gas attributions, not with any backfill that may be happening because of those attributions. So in an attempt to reduce the secondary dispatch, which is an atmospheric cost, and we don't want to completely ignore it, we introduce constraints that limit the attribution based on a reference that we calculate as the counterfactual. Maybe we can go to the next slide. So we have a counterfactual approach that I call here the KSO method. This is Valgufer, what is approved. And in this counterfactual, the solution is exactly like the IFM solution. Basically, we solve the IFM problem, but there is one significant difference, and that is the one that we ignore greenhouse gas attribution bids. So we ignore the effect of the greenhouse gas attribution without changing the problem in any other way. So with the constraint that we allocate imports to greenhouse gas regulation area to these attributions, without bids, there are no attributions, so therefore there is no import, there is no net import to the greenhouse gas regulation areas in the counterfactual solution. Other than that, the problem stays the same as the IFM, so of course we allow optimal transfers between balancing authority areas, so we allow economic displacement that could happen between resources outside the greenhouse gas regulation area. Another approach, which was introduced by Vistra and some others, is a similar problem for the counterfactual, with the notable difference that transfers between balancing authority areas are either not allowed or somehow are restricted or limited. And we wanted to present something different here, and I want to be clear about our intentions. We do not propose this to be a replacement for what we have already filed and what we have designed for, but we proposed it as an alternative to be considered among other alternatives that we have been considering in the context of this work group. And what makes it a little different from what we have so far is that it moves in the opposite direction. It moves in a direction where it allows more optimization to happen in the counterfactual. And for lack of any better name, we call it the no GHG cost, because we solve, again, a problem that is very similar to the IFM problem, but we ignore all greenhouse gas costs. So not only the greenhouse gas bids, but also the greenhouse gas cost component of energy bids for resources that are inside greenhouse gas regulation areas. So this is a solution that basically brings a counterfactual where there is no greenhouse gas regulation cost anywhere in the market footprint. This solution allows for an optimal net import into greenhouse gas regulation areas as it would naturally happen because of economic displacement based solely on energy bids that do not include any greenhouse gas cost. And of course, we also allow optimal transfers between balancing authority areas like IFM would. So it's the lowest possible economic outcome that you can have because of obviously considering greenhouse gas costs increases the cost of your solution. So let's go to the next slide and provide some more context for these methods. Let me start with the ISO method. We take this as a reference here to have some comparison. The greenhouse gas counterfactual is really an answer to a hypothetical question. That's what the counterfactual is, right? And the question here for the ISO method is, what would have been the optimal solution if greenhouse gas regulation areas were not in the market footprint? So we're actually trying to find an optimal solution for the external system outside of greenhouse gas regulation areas. Why? We want to get a reference, right? Again, to limit secondary dispatch when we attribute to these resources, we want to attribute, if possible, energy that is not in the counterfactual reference that would have happened anyway if these greenhouse gas regulation areas were not in the market footprint. So to achieve that, as I said, we ignore greenhouse gas bids, and therefore, without greenhouse gas bids, there is no attribution, and there is no net import into greenhouse gas regulation areas. But other than that, BAA to BAA transfers are optimally scheduled like in IFM. Next slide, please. So the Vista model is exactly the same. We solve the same problem. There is only one difference. So we still ignore greenhouse gas bids. So there's no net input to greenhouse gas regulation areas, but the BAA to BAA transfers, they're limited or restricted in some way. Maybe restricted completely, or there are some other restrictions. If they're completely not allowed, then it's BAA. In each BAA, you must have BAA supply meet the BAA demand. So you don't allow optimization between BAAs, even if they are outside the greenhouse gas regulation area. Let's go to the next slide. So for the no greenhouse gas cost method, the question is a little different, right? The counterfactual here answers the question, what would have been your optimal solution if there were not any greenhouse gas cost in the market footprint? So not only we ignore greenhouse gas bids, so therefore there are no attributions, we also ignore the greenhouse gas cost component of energy bids for internal resources, for resources inside greenhouse gas regulation areas, so that we achieve some parity. We ignore the greenhouse gas cost outside, we also ignore it inside, and then we solve the problem optimally, allowing optimal import into the greenhouse gas regulation areas that could happen naturally because of economic displacement, just using the energy bids. And in a very different way from the other methodologies, that net import into the greenhouse gas regulation areas that clear the counterfactual, we use it as a reference for attributions in the IFM. So with the ISO counterfactual, you have zero import, and then everything that is imported in the IFM gets an attribution. With this methodology, you don't have a zero import, you actually have an optimal reference import, which you don't attribute. So in the IFM, you attribute anything additional. So any additional import above the reference gets an attribution in this methodology. And of course, we allow all transfers between BAAs to be optimally scheduled, similar to IFM. So you have really the most optimal solution that you can get here. It's driven just by energy bids, no greenhouse gas cost. Let's go to the next slide. So how is this method different in terms of modeling and settlements from the ISO methodology? Just give me a second for my computer here to be alive. So as a review again, you know, we use the counterfactual schedule as a reference for greenhouse gas attributions. That's true in all methodologies. So we have greenhouse gas bids, which are specific now to greenhouse gas regulation areas, because you may have multiple greenhouse gas regulation areas. So an external resource can have multiple bids, one for its greenhouse gas regulation area. But then the sum of all the attributions, we have a constraint, right, where we don't attribute in aggregate for a specific resource more than the room that it has from the reference to the upper economic limit, which is the top of the energy bid. What we're trying to do, we're trying not to give an attribution, if that is possible, with the solution to energy that would have been scheduled anyway as a result of your counterfactual. So we're looking for any additional energy that will be scheduled, which will be, if it's attributed, then it's okay. We limit that to the difference. So that's common to all the methodologies, okay? And our mechanism for getting that solution is we have a constraint or a net import into a greenhouse gas regulation area is fully allocated to greenhouse gas attributions. In the case of the no GHG cost, is only the additional import above the reference. That allocation constraint is, of course, binding. It's an equality constraint because it's a direct attribution, unless, of course, there is a net export from the greenhouse gas regulation area. That's not the, in that case, the shadow price is zero, the constraint is not binding. But when it's binding, when there is an import and it's fully allocated to attributions, you have a shadow price for that constraint that is binding, and that is the what we call the marginal greenhouse gas cost for imports into that greenhouse gas regulation area. That is reflected as the fourth LMP component for all pricing nodes in that greenhouse gas regulation area. And I'm careful here to point out that I speak about greenhouse gas regulation areas, not BAAs. So in our methodology, you can consider that we solve simultaneously two hyperplanes. One is the BAAs, the plane where the BAAs are, and they have optimal transfers. That's your normal EDAM method, right? And then in parallel, you have another plane where you have the greenhouse gas regulation areas where different bids and different constraints are applied. We solve them simultaneously, okay? In settlements, the greenhouse gas attributions get a side payment, an additional payment. So you pay external resources for their energy that they produce based on their LMP, that's the total LMP, which for external resources does not have a value for what we call the marginal greenhouse gas cost, because this is only reflecting the cost of greenhouse gas regulation for imports into a greenhouse gas regulation area. So externally, that component is zero. So you use the LMP to pay for the energy that is produced, and then there's an additional payment for the attribution. And for that attribution, we use the marginal greenhouse gas cost for each greenhouse gas regulation area, because there might be multiple attributions to different areas. So each one is paid its own marginal cost for that specific area. And that's how the settlement works. Let's go to the next slide and see the difference for the no GHG cost methodology. And the difference comes from the fact that we do not attribute the entire net import into a greenhouse gas regulation area, but only additional net import above the counterfactual reference, because in that reference, we allowed actually optimal import into a greenhouse gas regulation area using only energy bids, no greenhouse gas cost. So now when we go into IFM, we potentially have additional net imports. These reflect the greenhouse gas cost on the bids of the external resources, and we make attributions for only these additional imports. In the market, anything that is within the counterfactual, like any import that will already happen in the counterfactual, it's a reference, we don't price that in the market solution, okay? Now, does this mean that it doesn't have a cost? Of course it has a cost. And then you can reflect this cost when you perform the settlement. You can either ignore the cost, all right, or you can assume that it has a cost at some average greenhouse gas cost price, at some average emission of all resources externally that they produce energy in the counterfactual solution. In either case, when we do the settlement for energy, we collect we being the market operator, would collect greenhouse gas revenue. And the greenhouse gas revenue in the ISO method is fully returned to the attributions. But here, because we don't explicitly price the counterfactual reference in the market solution, what happens is that you over-collect through the marginal settlement for the greenhouse gas revenue, so that when you pay the attributions for any additional imports, you're left off with some money, which is the marginal cost of your reference, all right? So we'll show some examples of how the market operator can stay neutral and how it can disperse this additional congestion revenue. So that is the, I believe, the elements that I wanted to go through. There is a table that comes in the next slide, which does a high-level comparison between the methods. I'm not going to go through that. We have presented it before. The idea here is that this greenhouse gas, this no GHG cost method, provides some actual advantages compared to the other two, depends on how you measure those, because you have a lower level for attributions. Because you only attribute a level of import above your reference, you have a lower volume for the attributions, so therefore you expect a lower volume for secondary dispatch. And also in settlements, if your marginal over collection for the greenhouse gas revenue is returned back to to the load in the greenhouse gas regulation area, one way or another, as we're going to demonstrate here, essentially you also have a lower cost for the load in that greenhouse gas regulation area, and also for outside, because now you have a fully optimal reference, so it reduces your costs. Now, there's a high-level observations. Of course, you need to take them with a grain of salt, because you need to do really thorough analysis with examples to demonstrate that. And at this point, I would like to go to the example that we put together that shows how this method works and how it compares with the ISO method.
George, would you have a question right now from Tally, or did you want to wait until we go to questions?
We can go through the question, although some of these questions may become more relevant and more meaningful as we walk through this example, and maybe some of the questions are going to be answered too. But let's have some pressing questions now before we go through the example.
Hi, George. It's Callie Wells with WPTF. I actually was able to go through your slides earlier, so I appreciate you guys posting those ahead of the meeting. So my question I have for you now actually is not in the upcoming slides. So I appreciate you kind of walking through all the three different potential counterfactuals and doing that high-level comparison. When I think about the different options, I think there's another character, maybe that's not the right word, but there's another element of each of them that makes them slightly different from one another that I think at some point would be really useful to fold into the policy conversation. And that's, as you mentioned, each of them slightly has a different secondary dispatch aspect to it. And all of them, though, has that constraint to where the amount that they can be attributed is limited to, I'm going to just say PMAX, but that upper economic limit to the reference level. And what that's defining is the amount of excess energy or surplus that we all agree would be an appropriate or an accurate value to assume, okay, that can potentially be attributed. Now, because each of those have different counterfactuals and different assumptions, what is ultimately being defined as excess or surplus energy differs between all three of those. So I just wanted to flag that now, and maybe I don't want to take away from the examples that you're going to walk us through, but hopefully, Anya, at some point in the policy conversation, we can bring that in when we're looking at the three different counterfactuals, because in my mind, they do define the excess or surplus energy differently. And I think that's a policy discussion that we need to have as to, okay, what do we feel is most appropriate for this market design? So thank you for letting me get that in before you go through these very detailed examples.
Thank you, Callie. And I admit that I'm not very familiar with the concept of the surplus energy. I was struggling in the past to understand it myself, so I think this would be useful even for me to see how it is defined and how it could be different in this counterfactual. So I'm also interested to see how this conversation will play out. If we don't have any more questions, maybe we can double through the examples here. And we use an example that we have used in the past to illustrate how generally the greenhouse gas methodology would work and how the pricing takes place. So it's an example that has three balancing authority areas, A, B, and C, and a greenhouse gas regulation area that is partially overlapping with BAAA, that's greenhouse gas area 1, and another one, greenhouse gas area 2, that partially overlaps with BAAB. So BAAC is not overlapping with any greenhouse gas area, so you can say that C and the portions of A and B that are outside the greenhouse gas regulation areas establish what we call, for better or worse, greenhouse gas area 0, which is really the area that does not have greenhouse gas regulation cost. Again, I will bring in the parallel that we're solving two planes at the same time. You have the BAA plane where you see these three BAAs with exchange, optimal exchange of energy. These are your blue arrows. These are your BAA to BAA transfers on that plane. And then you have another plane that sits on top of it, if you will, to visualize it, where you have the greenhouse gas regulation areas, 1 and 2, and greenhouse gas regulation area 0. And you have what we call a greenhouse gas transfer from area 0 to area 1. We saw that with red color, and from area 0 to area 2, which we saw with green color. So you have greenhouse gas transfers in one plane and BAA to BAA transfers in the other plane, and we simultaneously solve the whole thing. You can see that we have a generator and a load in each area and some more for each BAA. And we can go now to the next slide to see some schedules and bids. So that's just the network that we're going to use. Next slide, please. Thank you. So there's a lot of things going on here, right? We have many bids. So I'm using a coloring scheme to tell them apart when they're all relevant in a slide. So we're showing with black the energy bids and the schedules. We assume that the loads have schedules in the IFM, right? And we use red color to show the greenhouse gas bid for the attribution to area 1, and a green color for the greenhouse gas bid to attribution to area 2. And we're going to use brown for the reference and purple for the optimal solution. Now, what is important here for the NOGHE cost methodology is to extract, if I may use that word, the greenhouse gas cost from the energy bid of resources inside greenhouse gas regulation areas. These are G1 and G2. So you can see that the total bid, which is submitted in the market, is $75 for G1 and $70 for G2. But we have some methodology, some way of extracting how much of that energy bid is for the cost of greenhouse gas regulation in these areas. And it's immaterial for this example how we do that, although a simple way would be without having the participants submit it separately, which will require new APIs, work with cyber, blah, blah. A simple way would be to find how much this is in the DEB, because the DEB, the default energy bid, has a component for greenhouse gas cost, and it is known. So we can assume here that we find how much that is, and we will extract that piece when we run the counterfactual, okay? Because we said the counterfactual does not have any greenhouse gas costs. So these are all the bits that you have here, and let's take one resource here to explain. You look at resource C3, all right? It's a 100 megawatt resource. We assume that all resources are continuous here for this example. No intertemporal constraints. It's just one interval, 1 hour in the market of the day-ahead market. 100 megawatt is the capacity that is in the market, and it's bidding at $55. That's the energy bid. And it has 2 additional bids for greenhouse gas. Has a $3 for attribution to area 1, that's the red, and $8 for attribution to area 2, that's the green. The same thing happens for all external resources that can have greenhouse gas attributions. And for the internal resources, you can see that the $70 bid for G1, it really includes a $35 component for the greenhouse gas regulation of area 1, and similarly for area 2, the $70 energy bid for G2 has a $40 component for greenhouse gas cost that we find out. And assume that the load self-schedules. So you have a total of 400 megawatts load in each PAA and 100 megawatts in PAAC. So these are the bids. We can go now to the next slide and find out what will be the greenhouse gas reference. For this, we ignore all the greenhouse gas bids. So you can see all the red and the green bids for greenhouse gas attributions. They're not in the problem. We also extract and delete the greenhouse gas cost from the energy bids of G1 and G2. So now in this solution, the energy bid is only $40 and $30 respectively, right? They don't include the greenhouse gas cost. And we will attempt to find the solution to this problem as if there was no greenhouse gas regulation anywhere. That's the objective of this no GHG cost counterfactual. Simple problem to solve here, right? We have a total of 900 megawatt of load. That is self-scheduled. So we can load the resources in merit order. G5 and G6 are the cheapest ones, so they're going to be loaded fully at 400. The next one is at 35. I think G2 is next, so it's going to be loaded at 200. We have 600. The next one is G7, another 200. And we're at 800. We need another 100 megawatts. That will come from the next resource in merit order is G1 at $40. Okay, so your brown numbers that you see here is the result of the no GHG cost reference pass. 600 megawatts are generated in area C. With a 100 megawatt load, you have 500 megawatt export, so you can see the BA to BA transfers are 300 and 200. Not very important for the reference pass. We're looking at the greenhouse gas transfers, the T1 and T2. So if we look at GHG area 1, you have 100 megawatt generation to 150 megawatt of load, so 150 megawatt is an import, all right? That's your reference import. This is what is optimally scheduled here. And under this counterfactual is what would have been scheduled if there was no greenhouse gas cost in your market solution. Similarly for area 2, you have a 200 megawatt generation, 250 megawatt of load. So there's a 50 megawatt net import into area 2 to balance area 2. And that's your reference import for area 2. Remember these numbers because they will become important now in the IFM solution, which we'll go to. I don't think there are any questions on this, but I'll ask if there are any questions. This is a straightforward solution. I don't see any hands. Oh, no, there is a hand. Okay, let's see.
First up, we have Camille.
Hi, I'm sorry. I missed, unfortunately, the first half hour of this workshop. And I'm just a little confused about what we're talking about here because I thought the reference pass for in EDAM, one didn't allow any imports into GHG areas. So what's, and also, so I'm just like, I'm just a little lost.
And you're correct. You're correct. The ISO counterfactual we have in the design, we have as a filed and approved by FERC, indeed does not allow imports into the greenhouse gas regulation area. What we're showing here is an example of an alternative greenhouse gas counterfactual, which will actually optimize imports into greenhouse gas regulation areas using only energy bids for external resources and only energy bids free from the greenhouse gas cost component for internal generators to greenhouse gas areas. So it's a different counterfactual solution, an alternative. So didn't mean to confuse you here, but since you missed the introduction.
And I think I've seen this discussed in previous workshops, this alternative. I guess I wanted to make sure we were talking about this alternative, which is not actually currently what's implemented. It's not in the tariff. This is just exploring this idea, right?
Correct. And we will compare this with what the ISO counterfactual will solve as part of our example presentation. So
got it. Thank you.
For the time being, we're looking at the solution for the what we call the no GHG cost reference pass alternative. Let's go to the next slide.
We do also have one more question from Stuart.
Oh, I'm sorry. Yes, please go ahead.
George, thank you. No questions on the example, but just backing up to where you stated that the methodology for determining the GHG cost and the GHG area is not important and just relying on the DEB. I would say it would be better to have participants submit GHG bid others, understanding the impact of those submissions, because not only would it aid in your particular example if it were to go forward, but it would also aid in reporting and other elements related to overall GHG costs. So a slight difference on that particular element.
I see. You're not referring to the greenhouse gas bids because those are submitted by participants. You're referring to the greenhouse gas cost component of energy bids for resources inside greenhouse gas regulation areas. Am I correct?
Correct, George. And it's better, I believe, to have those separated out at some time in the future. It better reflect maybe difference between California, Washington, and maybe others, and just also would be better because the DEB probably doesn't reflect, change in real-time conditions when it comes to establishing a reference point. That's all.
Yeah, we could talk about that at some point if this method becomes relevant and gets more traction. We're only proposing it as a potential alternative here to just have things to consider. Yeah, as I mentioned, there are different ways of how you can do that. It could be submitted by the participant. I see this as more work on our part because we have to validate it. Of course, we can validate against what is in the DEB, but still being submitted by the participant or anyway. And as I said earlier, and you considered this doesn't have a material impact on the example here, this is just a mechanism about how we can extract that greenhouse gas cost component to not consider it in this reference pass. So let's move on to the next slide and see how IFM will solve this problem. And I'll give this in two parts to walk a little bit slowly through the example because there's a lot of moving parts. So we have to find a solution now in IFM that displaces economically the more expensive resources, G1 and G2, that have a reference solution. In the reference pass, they didn't have the $35 and $40 adder here for the greenhouse gas cost. The bid was $75 and $70. So now there is a potential for economic displacement for those 100 megawatts at G1 and 200 megawatts at G2 got in the reference pass. And we'll do it in parts. We'll do the most expensive part first, which is area 1. Those $100 are valued at $75, right? And let's find the solution for attributions to area 1 first, and then we'll move to area 2 to do it in 2 steps so that we walk through a little bit slower. So we find the cheapest energy that can be used to displace those 100 megawatts from G1. So we're looking at the bids. If we look at G3, all right, the cost of energy from G3, of an attribution from G3 is $55 energy cost plus $3 greenhouse gas cost, right? So it's a total of 58. For G4 is 50 plus 4, 54, okay? And for 5, 6, and 7, 5, 6, and 7, their cost, the greenhouse gas cost is now immaterial because they were fully loaded in the reference pass. You can see that 200 megawatts is their schedule, so there's no room to have any attributions. G8 has room, it was not scheduled in the reference pass, has a 200 megawatt potential attribution, but that will be at 60 plus $262. So that's expensive compared to the other choices. So the choice that makes sense here economically is G4 at $54, right? Because G3 is at $58. So the optimization will award 100 megawatt attribution to G4, so its schedule is going to go to 100 megawatts. That's its maximum, right? And we'll get 100 megawatt attribution to displace economically G1 from 100 in the reference down to 0 in the optimal solution, okay? And that will increase the greenhouse gas imports into area 1 from 150, which was the reference, plus the 100 for the attribution now in the IFM, it will increase it to 250, okay? So that's first part of the solution, that we economically displaced the $75 cost for this 100 megawatt reference of G1. We'll do the same now for the 200 megawatt for G2 at $70. So let's go to the next slide. All right. So again, we're looking at our bids. G3 can provide this energy at 55 plus 8, that's $63. G4 does not have any room anymore because it got fully attribution for the full attribution for G1, so there's no more room. G8 has room at the cost of $60 per $7 for the greenhouse gas bid for area 2. So obviously G3 is the next in merit order. So it will be scheduled up to 100 megawatts and we'll get 100 megawatt attribution, all right, for area 2. That will displace 100 megawatts of G2. We have another 100. So the next one is going to come from G8. That's the only resource that has available capacity. So G8 is going to be scheduled at 100 megawatts and we'll get 100 megawatt attribution for area 2. So we have a total of 200 megawatts attributed for area 2 on top of the 50, which was the reference. So there's a total of 250 megawatt net import into area 2, 250 of which, 200 of which is attributed, as is shown in the solution. So this is our IFM solution in terms of megawatts. Let me take a pause here and see if there is any question on how we came up with these numbers before we go to show the prices.
I'm not seeing any hands raised at this time.
Okay. So let's go to the next slide then and see the prices. So the only resource that has available capacity here, everything else is scheduled fully except G1 and G2, that they were expensive, they were fully displaced. G3, G4, 5, 6, and 7, they're all fully loaded. G8 is scheduled at 100 megawatts, so that's your marginal resource here, right? And the marginal resource for providing $60 energy for any potential additional load at L5, L3, or L4, right? In area 0, it will be provided by G8 at the cost of $60. So $60 is your marginal energy cost for C, for A, for B. There are no transfer constraints here. Those BA to BA transfers, intentionally in this example, to keep things simple, we didn't put any scheduling limit. So without BA to BA transfers at the scheduling limit, obviously there's no price separation between the BAs in terms of marginal energy cost, so they all have the same marginal energy cost of $60. All right, let's look now into area 1 and area 2. What would be the marginal cost of serving an additional load at L1? All right. The cheapest way to serve load at L1, obviously it's not from G1, that's at $75. It's from G8 at 60 plus 7, $67, right? I made a mistake, not 60 plus 7, but 60 plus 2. 2 is the greenhouse gas bid for area 1 from G8, the red one. So at $62, so therefore the price, the LMP in GHG area 1 is $62. That is the $60 marginal energy cost plus the $2 difference is the marginal greenhouse gas cost. It's the marginal cost of imports into area 1, and it's set by the greenhouse gas bid of G8, which is at $2. As you can see here, $2 is not the higher cost that we used in greenhouse gas bids. G4 also had a 100 megawatt attribution, and it was priced at $4, right? But it was maxed out, and therefore it dropped from the price. So your marginal greenhouse gas cost is $2. So you can see here the interplay between the energy bid and the greenhouse gas bid. The marginal greenhouse gas cost is not necessarily set by your highest accepted marginal greenhouse gas bid, because it's the combination of the energy bid and the greenhouse gas bid that establishes your merit order and your optimal solution. So here, G4 was cheaper than G8, but you took all of it. So G8 becomes a marginal resource. In this case, both for energy and greenhouse gas cost. That doesn't always happen. In this example, that's the case. But it's interesting to note and always to remember that the fact that you have a $4 greenhouse gas cost that was selected doesn't mean that it sets the price, because the price is set by the $2 greenhouse gas cost of the marginal resource G8. You may wonder, wait a minute, are we going to pay $2, the marginal greenhouse gas cost, for the 100 megawatt attribution that G4 has? Yes, we are. That's the marginal price for that attribution. But then it bids $4, we pay $2, it's going to be at a loss? Not really, because it also gets an energy payment for the 100 megawatt of energy at $60. So it's made off. No one is going to lose money here in the optimal solution. If we look at the greenhouse gas area 2, similarly, an additional load at L2 will be served in the most economic way. Instead of $70 for G2, it will be 60 plus 7, $67 from G8. So the marginal price, the LMP for L2 and G2 is $67. $60 your marginal energy cost from the BAAB, right? And the difference of $7 is the marginal greenhouse gas cost for imports into area 2, set by the greenhouse gas bid of G8, the marginal resource, at $7. Let's pause for questions.
First question, we have a hand raised from Camille.
Yes.
Hi. I just want to thank Kaiko for just exploring this counterfactual as an idea, because I do think it gets at an important point of separating just the cost of serving load within GHG areas versus the additional cost put on it by being a GHG area. And I understand that for purposes of running your market and recovering cost, attribution really only occurs to recover that cost for the part of it being the GHG area. But I do want to, if you can continue down this road of thinking about this method, encourage you to also think about how we at the Department of Ecology, as a regulator, as the operator of the Cap and Invest program uses attribution as well, which is we use the resources that you say are, we plan on using the resources that you say are attributed to assess a compliance obligation for emissions associated with that import into Washington. And the big red flag that I'm seeing, not from a market perspective, but just from us like operating our rule perspective here, is that the CAISO is only attributing a portion of the imports into the GHG area, which is fine for like your purposes of your goals, but that's something that we rely upon, is saying this resource is coming into Washington, and then we can assess an emissions for it. And if essentially we have the market telling us, oh, 250 came in, but we can only tell you where 100 of it came from, that is like gonna really put a monkey wrench in what we're doing and how we've planned. Like we essentially have been planning and will continue to plan that any imports as a result of EDAM or EIM will be attributed so that we can assess emissions with it. So that's just something that I see here. Obviously, this isn't in operation or implementation yet, and just something for you guys to think about. Hopefully, we can work together if this gets further down.
Yes, thanks for that. That's an excellent question, and one that was raised in my head as well. So when we get to the settlement, you'll see that we have in the proposal a mechanism to address that. So if you can hold your thoughts, I think you'll see how it can be handled. But then I guess I mentioned this initially, that the motivation for having this proposal here is not to propose it as a substitution of what we have as the ISO methodology, but to explain essentially that there are multiple ways that you can consider as a counterfactual, and it has its own philosophy. And we want to present some other alternative that, could be a contender if we want to make some changes in the future. I don't advocate to make any changes. It's just purely for information. And again, this may not be the only alternative. I'm sure there would be others. So I just want to point out what potential counterfactuals we can have, and this is one of them. And it does have that effect, which makes it different from the ISO methodology, that it only attributes imports above the reference. So there is a question that you raised. What do you do with the reference? So we're going to talk about this when we discuss a little bit the settlement at the end, where we have some potential options about how it can be addressed. So we saw the solution for the no-GHG cost, and we will proceed solving exactly the same problem with the ISO counterfactual to highlight any changes and then compare them. So let's go to, I'm assuming if there are no more questions on this, we'll move on to solving this problem with the ISO counterfactual.
We do have one more question in the chat from Andrew Valenis asking, quote, can you walk through that again? Why the $2 greenhouse gas set the marginal cost and not the $4, even though the $4 is higher, end quote?
Yes. Yeah, so in simple terms, it's not the $4 that is relevant, but the sum of the $4 and the $50 energy from G4. So essentially, the import attributed to G4 has a cost of $50 energy plus $4 greenhouse gas cost. A total is $54, replacing a $75 internal resource. All right, so that's an economic displacement that happens not as a single dimension of the energy cost, but also energy plus the cost of greenhouse gas regulation for imports into Area 1. So a total cost is 54. And you max this, and then you go to the next total cost, which is $60 energy plus $2 greenhouse gas cost from G8. So you're comparing the 54 with the 62, not really the 4 and the 2, and that's why I made the comment. It's not the 4 and the 2% that make the difference here, but you're comparing the total cost, which is 54 versus 62. And because 62 is marginal, then $60 your marginal energy cost, and $2 is the additional cost for, and it's marginal cost for greenhouse gas attributions to Area 1, because your next megawatt for L1 will only be served economically, most economically, from G8 at the cost of $60 energy plus $2 greenhouse gas cost for a total of 62. And that's more expensive than 54, which you already used it, and it's not in the pricing anymore because it's now inframargin. I hope that answer is satisfactory. Otherwise, we can get back to it. Let's go on to the next slide and proceed with the solving the example using the ISO reference method. Thank you. So in the ISO reference, as you know, we don't allow any imports into the greenhouse gas regulation area. So we, because we ignore the greenhouse gas bids, so you can see that there are no greenhouse gas bids, but we do take into consideration the entire bid for internal resources. So G1 is at $75, G2 at $70. Without imports, you can see that the reference import is 0, right, for T1 and T2. The 250 megawatt load in Area 1 has to be met by G1. So G1 will be loaded at 250. In Area 2, all you can get from G2 is 200. There's no more capacity in the market, so the 250 megawatt self-schedule for the load 2 will have to be cut down to 200. It's got the penalty cost. And we're not very much concerned about that because we're looking also, the most important is how external resources are loaded. So externally, we have 300 megawatt load in BAES A and B and 100 megawatt load in BAES C. So we have a total of 400 megawatt of load. And the cheaper resources that can meet that load is G5 and G6. So G5 and G6 are loaded fully at 200 megawatts, and that's your reference for G5 and G6. G7 and G8 get a 0 reference as well as C3 and C4. That's what's important in the ISO reference pass. Now, that's your reference. Let's go to the IFM and see how we're going to solve this problem now in the IFM. Next slide, please. Thank you. Here I don't do it in steps. We'll do it all in one swoop. We're more proficient now. So again, the idea is to solve it with superposition. It's a linear system here, linear problem. So we're gonna first solve the highest cost. We'll do the highest cost displacement, right? What's the highest cost? What do we have here? We have 250 megawatts, $75, 200 megawatts at $70 in Area 2, but don't forget that we dropped the load in Area 2 from 250 to 200, so that was a penalty. That's an even higher cost. So first what the IFM is going to do is going to import 50 megawatts into Area 2 to restore the load back to 250. So what's the cheapest energy that you can get into Area 2? From G3, that will be 55 plus 8, right? It's 63. From G4 is 50 plus 9, 59. Okay, that's cheaper. 5 and 6 are fully loaded, so you cannot get any attributions to them. G7, the cost for Area 2 will be 35 plus 5. That's $40. That's the cheapest alternative. So you're going to have a 50 megawatt attribution from G7. All right, to Area 2, okay, that's your green 50 and the attribution for G7. So that's first thing is going to happen. That will restore the load back to 250 for L2, eliminating the penalty cost that we had in the reference. Next, we're looking at the bids. Well, Z1, the 250 megawatts, it's at $75. So that's the next cost we'll try to displace. So we need 250 megawatts coming into area 1 to displace fully G1 from 250 down to 0. What's the cheapest source for this import? We're looking at our bids again. From G3 is 55 plus 3, 58. From G4 is 54. That's cheaper. And from 7, it's, 7 is 35 plus 1, 36. So G7 is cheaper. We used already 50. There's another 150 room, so we're going to give another 150 to G7 as an attribution for area 1, okay? And G7 will be fully loaded at 200. Okay, so we've got 150. Out of the 250, we need another 100. What's the next bid? If we get from G8, is 62, 60 plus 2. So we had a cheaper one here, which was 54. So 100 megawatts will come from G4. So G4 will be loaded to 100 megawatts. We will get an attribution for 100 for area 1. We have a total attribution of 250 now coming here. 150 from 7, 100 from G4, right? 250 coming in, displacing fully G1. So we displaced the $75 resource with cheaper resources. Next, we're looking at area 2. We have a 200 megawatt of at $70 for area 2. From G3, it will cost 55 plus 8, $63. G4 does not have any room. We took it fully. G7, we took it fully. G8, it has room. It can give you at 67. So obviously, the first 100 megawatt is going to come here in G3 at 55 plus 8, 63. That's cheaper. So we'll give 100 megawatt attribution to G3 for area 2. That's 100 megawatt. We need another 100 for full displacement of G2. It's more expensive. The other 100 will come from G8. So G8 will be loaded 100 megawatts, and it's going to get 100 megawatt attribution at the cost of 60 plus 7 to displace fully G2. So in our optimal solution, we have G1 and G2 fully displaced. They're at 0. G3 loaded 100 megawatts, maxed, with 100 megawatt attribution for area 2. G4 also loaded 100 megawatts with 100 megawatt attribution for area 1 now. And then here, 5 and 6 were already loaded fully in the reference. 7 is loaded fully with an attribution of 150 for area 1 and 50 for area 2. And then G8 is also a marginal resource here in this solution as well, where it's loaded at 100 megawatts with 100 megawatt attribution for area 2. Total attributions to area 1 and area 2, 250 megawatts. This is the breakdown, as you can see with our schedules here. So, in megawatts, for schedules, the solution is the same. In attributions, it's different, because here we have a full attribution of the entire import for 250 megawatts. In the no-GHG costs, we only attributed something above the reference, and we had non-zero reference. So your attributions are different. Let's go to the next slide and see the prices. Thank you. So G8 is still the marginal resource in the solution, so it will set the marginal energy cost to $60. It so happens that in this simple example, and maybe simple is perhaps not appropriate to say, this is as complicated as it needs to be to illustrate what's going on, but nevertheless, regarding your real solution, it's simple. So in this simple case, we have both methods giving you the same pricing. So you have the same marginal prices. The payments and attributions are different. but the prices are still the same. There's $60 marginal energy cost. The marginal cost of serving L1 is still $62 from G8. That's a marginal resource at 60 plus 2, 62. So $2 is again the marginal greenhouse gas cost for imports into Area 1, same as before. And marginal cost for serving L2 is 60 plus 7, 67, right? So $7 is the marginal greenhouse gas cost for imports into Area 2. So marginal prices are the same, but the megawatts are different for the attributions, obviously, so we have a difference in settlements. Before we go to settlements, let's make sure that everybody is comfortable and understanding the solution here with the ISO counterfactual.
We do have one hand raised by Callie.
Yes, please, Kelly.
Hey, George, it's Callie Wells with WPTF. Sorry, I didn't quite fully understand why, for G7, why doesn't it have the full 200 attributed to Area 1? Why is it split 150 and 50?
Yeah, so are you talking for Area 2 or for Area 1?
Well, so I would think when I look at these, I would think that the full 200 megawatt dispatch for G7 would be fully attributed to Area 1 because it would be $36. But it splits for some reason 150 megawatts to Area 1 at 36 and 50 to Area 2 at 40.
Yes, first I displaced the highest cost. I went through let's say a merit order solution here. So I used the cheapest energy first to displace the highest cost. And the highest cost in the system here is the $50, the 50 megawatt curtailment of L2. If we go back 2 slides to see the ISO counterfactual. Is it possible to go back 2 slides?
Yes.
Okay. Thank you. So here, because there's no import into Area 2 in the counterfactual, you have a 250 megawatt load and a 200 megawatt resource. So the resource will be scheduled fully at 200, but the 250 megawatt of the load subschedule cannot be served. So your result of your reference pass will curtail the load from 250 to 200, right? At a penalty. So that's a penalty cost. So let's advance again 2 slides to the solution for the IFM. So the IFM will obviously try to not have any load self-schedule cuts because that's a high cost. We'll first substitute for that. So consider this 50 megawatt load, all right, as the highest target for displacement. So again, I'm solving the problem here in merit order. That's not how it's done, of course. It's all simultaneously done. And there is a level of redundancy here with the numbers that I have selected. So we know for sure G7 is going to get a full schedule at 200 megawatts and will have full attributions. Now, as far as the optimal solution goes, maybe it's a little flat and doesn't matter if it's going to get 200 megawatt attribution for Area 1 or if it's going to split 150-50 the way I have it here. The important thing here is that when I try to find a solution in some systematic way to show you here in this example, I will use first the cheapest bit, which is G7, to first substitute for the highest cost, which is the 50 megawatt load from L2, because that's a penalty cost. So if I consider this solution as incremental, if you allow me, to the reference solution, then the first attribution will happen here is to G7 for 50 megawatts for Area 2, right? Now, when you solve the problem independently in IFM, as I said, it's a flat solution. You still have the same 200 megawatts schedule, but the attributions may vary slightly if it is a flat solution, and your optimal solution is still the same cost. You're following me? But in an incremental position way to show you here some solution that we can derive, I gave the attribution of 50 megawatts first to G7, incrementally from your reference solution where I had a 50 megawatt cut of load at a high cost. I displaced that first, if you allow me to say it that way.
Okay, yeah, but in reality, though, it's done simultaneously. The load between G1 and G2 has the same penalty price. So in reality, G7 should be 200 to G1 or to area 1. Because if the objective function is minimizing the total cost, it's looking at the resource cost. So I understand when you like walked through these, it was done sequentially, but I think in reality, though, G7 would be fully attributed to area 1. Because it does, I know you said it doesn't like 150-50 split. At the end of the day, it's fully attributed, and that's true, but it would affect the revenues of G7 because the pricing between area 1 and area 2 that it would get is different. So, okay, I think I understand why you ended up this way.
Yeah.
But I think
Yeah,
when it's in the actual optimization, it would be slightly different.
Yeah, I didn't solve the problem as we say here independently. I try to solve it continuously in continuation of the reference to show some continuity and have some example that can be understood. What will happen in reality if we solve it independently? I haven't tried, so I don't know exactly. It appears that the solution is flat. So you may get different attribution. As long as the cost is still the lowest cost that you arrive at, it's flat solution, you may have different numbers that end up in the same overall cost. Now, as you point out, having the same overall cost of the objective function doesn't necessarily seem the same cost to each participant, but that's one of the problems of optimal solutions, that they are flat at the optimum, and it's difficult to have examples with nice rounded numbers that you can avoid this phenomenon. So anyway, I chose to solve it incrementally in a manner that anyone can follow. I don't know exactly what the solution would be if I solve it independently. For sure, the optimal solution should be the same in terms of total cost. The megawatts for specific resources may be slightly different because of the flatness of the solution. But can we go along with this so that we can solve the difference?
Yeah, I just want to make sure I wasn't missing anything because I think the attribution between G7, G4, and G8 would be different. Just want to make sure I wasn't missing anything fundamental as to why that happened. So thank you.
Yeah. Let's say that this is one of the optimal solutions. I think we can safely say that if the solution is flat. So let's go with that, and we'll see how the settlement differs now with these solutions for the non-GHG cost and for the ISO solution. So let's go to the next slide. And there are a lot of numbers here. I apologize. I put the settlement for both approaches in one slide so we can compare. I still use the color scheme that I used so far to make things simple to follow. So we have all the resources listed on the left. And the marginal price, this is the LMP for these resources. And remember that there are several components to that LMP. The purple is the energy, is your marginal energy cost, which is $60 throughout the grid, right? Because there's no price separation between the BAAs, no transfer congestion. And then you have others that are coming from the marginal greenhouse gas cost for resources within greenhouse gas area. So anything that is in area 1, it has a plus $2 for the cost of attribution to area 1, all right? And anything that is in area 2, it has a plus $7. So G1, it will see an LMP, a total LMP of 62. G2, a total LMP of 67. That's also true for L1 and L2. L3, L4, and L5 will see only the $60 marginal energy cost of the BAA because they're outside greenhouse gas regulation areas. And the resources that are external to greenhouse gas regulation areas, G3 through G8, 8, they see the $60 for their energy settlement plus $2 for the attributions that they may have to Area 1 and $7 for attributions that may have to Area 2. So if we look at the settlement for the ISO solution, then you can see that for each resource, G1 and G2, they're scheduled at 0, so there's no settlement for those. And the settlement for the load is straightforward. It's the price that is shown, the marginal price that's shown in the second column. I separated here to show the effect of the greenhouse gas regulation being the red and the green adder to L1 and L2. For generators, you have the payment for the energy production at $60, and then you have additional payment for the attribution. So G3, for example, has a 100 megawatt attribution to Area 2. That's your green 100 here. And for that, you will get a $7 payment. It's a site payment, $700. Similar G4 will be paid $6,000 for its energy schedule, that the $60 LFP. It also has a 100 megawatt attribution for Area 1 at $2, so it gets another $200 as a site payment for the attribution. And if you add all this up, you get a nice zero down here, which is what we expect to have in the IFM, because IFM gives you a balanced solution. If everything that is an intertie or anything like that is tagged at the schedule, then we expect everything to adapt and comes up to zero. So it's we call this a revenue neutral settlement for the market operator. There's no neutrality issue here. Whatever the market operator collects from the green and the red, which are the additional revenue because of the greenhouse gas cost, the marginal greenhouse gas cost for imports into areas, turns around and pays the attributions for it, and there is a one-to-one relationship for that, so that yields a zero net neutrality. Okay, this is nothing new here. You know that this is how it works. Okay, this is what we have in our FAD methodology in our design. Now, when we go to the no GHG cost, what happens is that for this particular example, your marginal prices are the same. They don't change. They apply the same way. And the energy schedule is the same. What is different is the attributions, your red and green numbers. You have a lower level of attribution. We explained that earlier because we only attribute imports above the reference, right? We don't attribute for the reference, so you have a lower level of attributions, which means lower side payments. You have lower payment for attributions, you have lower attributions. If you add up the numbers now of your settlement, you'll see that the market operator is not neutral, okay? It's collecting $650. Why is that? Because your energy settlement is on the total volume of generation and load for the greenhouse gas regulation area, and that settlement has a marginal greenhouse gas cost as a fourth component of the LMP. So you actually settle the net import into greenhouse gas regulation areas on the margin. But when you pay the attributions, you only pay the attributions above the reference. So the cost for the reference, it remains down here. So we'll go to the next slide and drill into that 650 to see where it's coming from. Thank you. It's coming from the marginal cost of the reference import. Remember, L1, the import reference for Area 1 was 150, and for Area 2 it was 50. And through our energy settlement on the margin, we priced this on the margin, was $2 the marginal cost for the 150 and $7 for the 50. So we have a total cost of $650. So it's priced on the margin, yet we don't pay any attributions because we don't make attributions for it. So how does the market operator stay neutral here? There are listing two options, and maybe more. The simplest option is we say we over-collected for the net import. We collected for the reference import on the margin, but we don't assign a cost to it. So what we over-collected, we return it to the load. So whatever was over-collected under option 1, the simplest option, we return it to the load. So if you go back one slide here, you'll see that L1 gets a 300 and L2 a 350 uplift. So if you go down here and see what they're paying, L1 is paying on the margin $500 for greenhouse gas cost for the imports, but it gets 300 through the uplift. So it reduces the marginal cost through the distribution of the over collection. Next slide, please. And that happens also for L2 that pays $70.50 but gets $350 back. So that's option 1. It's very simple, doesn't involve anything, can be done by the market operator. We return the over collection to the load. This is very similar to how we return the over collection for losses. It's a similar phenomenon. We collect for marginal losses in the energy settlement because there's a marginal loss component of the LMP. However, the cost of losses in the system is not marginal. The average cost of losses is less. It's really the cost of the losses at your marginal energy cost. And that's less than what you collect with the marginal cost through the marginal loss component. So there is a loss over collection that is very similar in nature, and that results to what we call the loss offset. It's an offset, and it's returned as part of the neutrality back to the measured load in its BAA. That's a BAA level neutrality. So this is very similar. You collect, but this is at the greenhouse gas regulation area level, so it's on the other plane, right? So you have a similar over collection because your energy settlement is pricing your reference import at the margin, and you don't assign a cost. It doesn't have a cost in the optimization, so you can return the over collection. That's option 1. Let's go to option 2. Option 2 realizes the fact that the reference import does have a cost. And as who was from Washington? Camille? Yeah, mentioned. So option 2 says, you know something, there is a cost for that import reference, and we know it's priced on the margin. Yes, its cost is not the margin anymore in the methodology, but we can find a cost, we can assign a cost. So one way of assigning a cost to it is based on an average greenhouse gas price. How do you find the average greenhouse gas price? I found it to be 33 cents and 167 for areas 1 and 2. For this, let's go back to, I don't know how many slides back. We'll go back to the ISO, not to the ISO, to the no-GHG cost reference solution, so several slides back. Let's find the reference pass from the no-GHG, a couple slides more back. Thank you, that's it. Okay, so yes, this one. So here we have, as you can see, we have a 150 megawatt reference import to area 1 and a 50 megawatt reference import to area 2. The market does not assign any cost, but it can calculate, we can calculate the cost because we know that this energy is coming from all these resources that are producing energy in the reference pass. Let's go one more slide next to see the prices. And it so happens that G5 and G6 are the resources that are, they're non-emitting. You can see that they have a zero greenhouse gas cost. So at least the energy that comes from G5 and G6, it doesn't have a greenhouse gas cost. But G7 has some greenhouse gas costs. We assume here for simplicity that these greenhouse gas costs are representative of what it costs to get energy from this resource to serve L1 and L2 in the reference solution. Another way would be to work with the emission rate and the carbon price, if there is one for each area. There are different ways, but in here, because we have greenhouse gas bids, I use the greenhouse gas bid. So let's see. For imports into area 1, okay, you have a total of 600 megawatt of energy generation, and 200 of it has a cost, has a dollar cost. So you have a $200 cost for 600 megawatt generation. You can calculate an average cost of $1/3 of a dollar. That's where the 33 cents came from. So your average greenhouse gas cost for that 150 reference to area 1 is 33 cents. We can do the same for area 2. For area 2, we have $1,000 cost for 600 megawatt of energy. You have an average cost of 5/6. So that's 1.67. That's where the $1.67 comes from. So this is a mechanism where you can calculate an average cost for your reference imports based on your reference solution. So let's go back again to that slide where we explain what we can do with a 650 megawatt dollar over collection. Must be maybe 5 slides after. Thank you. That's perfect. All right. So that's where we get the average greenhouse gas price for those imports. So now we can say, okay, then using this average price, we can actually say that, this 150 megawatt import reference to area 1 is not really free from greenhouse gas cost. It does have a cost that's based on that average price. It's $50. All right, 1/3 times 150. And similarly for area 2, the import of 50 megawatt reference has an $83 cost. So in option 2, we can take this and say, well, this is actually cost for those imports. So we can give it to the regulator. The regulator can either release instruments or they can have their own policy of how they use these funds, which represent the cost of these reference inputs for which we don't have explicit attribution or explicit responsibility. It comes to the load, basically. The load is getting the benefit of this reference, but now we assign a cost to it. It's not free. And then we only return to the load in this option 2, the overcollection above that average cost. All right? There are probably different ways that you can handle this. The intent is to find a way to stay revenue neutral, either by just returning it to the load and not getting in the business of the regulator or interfacing with the regulator, or telling the regulator that this is the cost for those imports, so it follows their process of assigning cost to every import. Came up as a discussion point here, and then we only return to the load the overcollection, which is a true representative of the overcollection, similar to the loss offset that I described earlier, where marginal losses, you collect for marginal losses a higher value than the average loss in the system, and then you return the money back to the load. This was the last slide. I just wanted to present this as an alternative for discussion purposes, and have an exchange of ideas. And there are other ways that you can do things different from what we have already in the design, if we're looking for discussion and exploration of potential solutions. Thank you.
We do have one hand raised, George, if you have a moment, from Stuart.
Yes, of course.
Hey, George, thanks for this. George, I'm just wondering, I like your approach to the reference imports, and you probably can figure out why, but why wouldn't we just apply the approach to the reference imports to all the imports? That negates the need for any attribution, which is where we have the problem is with the attribution. But if we apply this approach that you're advocating, which only applies at the moment to the reference imports, apply it to the whole import, then from a regulation standpoint, from a compliance standpoint, we're covered, we're paying for the appropriate amount of emissions, be it we've talked about average approaches before or marginal approaches. I just, this ability to eliminate attribution, which I think is at the root cause of this, and I've said it for many years now, would be a step in the right direction. So I really like your approach to the reference imports, but I for the life of me, cannot understand why we can't work towards just having that overall approach to imports into a GHG area and ultimately lower cost to consumers.
Excellent question, Stuart. Yes, and it will open up for some interesting discussion at this point, because essentially, how do we find the solution? We find the solution using greenhouse gas bids and attributions. So if you have a way where we find the solution using attributions based on greenhouse gas bids, and then we turn around and say, well, you can forget all that, all right, and we simply calculate the cost of all net import as an average, at an average cost, and we present this to the regulator. We say, okay, we solved our market, and this is our solution, and this is the net import that we have for its greenhouse gas area, and this has an average cost. We don't collect for that cost because we don't reflect the marginal greenhouse gas cost component in the LMP, so we don't collect for it, but the regulator can assign this cost to the load. That's an alternative. However, I don't consider it stable, because what would be the meaning of having those greenhouse gas bids if at the end they don't have relevance in the settlements? The bids lose their meaning. They can become anything. Basically, the participants are not obligated anymore to reflect their actual cost in the bid if they're not getting any revenue for it, if they're not financially binding. You see what I'm saying?
It's an excellent point, George, and one that we've stated before. That's why you have the regulator determine what that emission cost that's then applicable. You take that other entity, that generating entity, out of the picture so it remains meaningful. So, and we've covered this before a couple of years ago, but yeah, it's a great point.
Yeah, we doubled on that, but there are some other problems. Let me see. How can I show it to you? But let's go back a few slides. I'll show you why I think there is another problem that we need to solve before we go there. Let's go back to again to that no GHG reference bus. Thank you. So without GHG bids, we would be solving this problem in the IFM, all right? This is full optimization, all right? No GHG bids, right? Because we will calculate ex post what's the average cost of the imports. So 150/50 are optimal here, but there is one key element. Look at the bids that I'm using in this reference pass for the internal resources, G1 and G2. They don't have the greenhouse gas cost, which is part of the regulation for Area 1 and Area 2. So if I do this, the prices are not going to support the cost for producing energy for G1 and G2. And if I add them, if I have a $75 bid for G1 and a $70 for G2, now it's unfair because I don't have greenhouse gas cost outside, but I reflect the greenhouse gas cost in the internal bids. This is really a problem that you cannot solve. You either forget all the greenhouse gas cost or you put it all in. You cannot do half and half. So if you really want to have a fair competition between internal resources that are born with the cost of greenhouse gas regulation in their area and external resources where you cannot ignore the responsibility that they may have for greenhouse gas for their imports into the areas, you won't have an equitable solution. You give the upper hand to external resources because they can.
Yeah, I'm not.
Right.
Not proposing that at all, George. Fully recognise that, and would not agree if that were the case. I think we can take this one offline. I think your concern that you're raising, I think, is fully solvable, and that isn't that you're removing completely GHG, but how you calculate the GHG when it comes to compliance and payments is not determined by the third parties, my point, but it can be solved. We've talked about it before, and I'd be happy to revisit it. But I just welcome the suggestion on the way that you're working towards the imports on the reference pass. I think that ultimately could be used in the broader market. And I think if you look at the priced approach to the non-priced approach and reporting, and you start to focus on the imports, move away from attribution, things will start to coalesce at that point. So maybe we can take it offline, but thank you, George.
Absolutely. I know what you're thinking, and I know we exchanged discussions on this in the past.
Yeah. Just, can you get there quickly, please?
Sorry? What was that, Stuart? I lost the tail end of it.
No, I was just encouraging you to get to our approach more quickly. Thanks.
Yeah, well, I mean, you're thinking of having regulated greenhouse gas bids, not submitted by the participants, but constructed by the market operator with information on emission cost of this resource and the carbon cost or the cost of regulation for each area, without having responsibility on on greenhouse gas regulation. You just calculate it, you just use it as a method to find the solution, which is now an equitable solution because internal and external resources compete on equal footing. But then you turn around and you say, I'm not going to pay you because you don't have a, I'm not going to pay for attributions, you don't have a responsibility, a greenhouse gas responsibility. We turn it back to the load. We say, well, we'll assign that responsibility based on whatever cost came out of these regulated costs, bid costs, not submitted by the participants. I mean, that's one way to do it. I think this is the context of our earlier discussions on this.
Yeah, and I think more of the regulator would determine the carbon cost because we have the emission factor, can run everything from there. But I just opened that up based on some questions I saw from CARB recently. That may, I'll just leave it there. Thanks.
Thank you.
Next, we have a hand raised by Callie.
Yes, Callie.
Hey, George. Hey, it's Callie Wells with WPTF again. Thank you so much for walking through all this stuff. It's really helpful to wrap my mind around kind of what you meant last meeting when you started to introduce this approach. I guess a couple asks so that we could continue thinking about these options. The first one would be if there's any way you can do something similar for the Vistra approach. That way we have all three side by side and really can look at the pros and cons of all of those approaches. And then also, you're probably going to cringe when I ask this, so I apologize in advance. If you happen to have an Excel model where these different options are laid out so we can mess around with it.
I didn't make one. I was lazy.
George! No, that's because I think when we get like, I think this is a great starting point for thinking through the different approaches, but a lot of the differences between them are going to come into the nuances when we start seeing differences in the ultimate price, the attribution and the dispatch. So if at some point we could maybe have an Excel model where we can mess around with the bids and the prices and really get comfortable with all the differences between the three, that would be really useful. But I know it takes quite a bit of time to do that. So understand. And I guess the last,
the problem, Kelly, on this one, the problem that I had done in the past is that these examples and these models are getting increasingly bigger in size. So I may be able to come up with a solver to do it, but I may need to use the proprietary solver that Frontline has. The basic one that comes with Excel has its limitations, and in the past I have hit those limitations. Now, so I don't know if a problem of that size and the complexity that you're looking for will still fit in the standard Excel capability, and if I get the time, I'll look into it, but I can't promise that it does, in which case, if I solve it, I'll solve it with a premium solver, which is not generally available to the public, so it may be of limited use to you and other stakeholders, but I'll have a look. It's just getting very complicated, even at this level with simple examples to try to formulate a problem and solve it optimally.
Yes,
but I
and
know what
I
you're
appreciate that. Yeah, I thought in the past when we were going through this in the EDAM, there was a model out there, so I was thinking it would just be slightly tweaking that to add the different constraints in the counterfactual, but that might have been another policy effort where a model was put out there, but I understand the complexity involved. And the last ask is kind of going back to my first question about defining surplus or excess clean energy and how that differs between these approaches. I think another good element to think through in terms of how they differ is, one of the main reasons for these counterfactuals is to make sure that the GHG and the non-GHG areas all have equitable access to that surplus energy. So thinking through how these different approaches line up with that policy goal. So I don't know if maybe adding those couple items on your slide 15 table would be helpful for the next.
We couldn't hear. I don't know if it's only me, but I couldn't hear you very well. It was fading in and out. I don't know if your audio is running out of battery or something, but I couldn't get all of that. Maybe you can send it by email, this ask, and we'll look at it, because I know it's a little long to ask you to type it in the chat, and I couldn't hear all of it. It was coming in and out. So how about if you can send it to us through an email?
Yes, will do.
Thank you.
All right, thanks, George.
We have one more hand raised by Camille.
Yes.
Hi, yes, I want to ask a quick question and then give some comment. And my quick question is the reference paths that exist now.
Yes.
Within EDAM. And this, I understand you preface that this is we're exploring ideas right now, that this is not a promise to make any changes in the tariff or actual implementation. But I'm just curious, if there were to be any changes in the tariff or implementation, just if, kind of like whatever they are, what are general timelines for that? Is that something that could be turned around in 3 months, 6 months, 2 years? Like, I just don't have a sense of it. And I think having a sense of that would lower my a little bit about when I'm thinking about this discussion.
Yes, it's a tough question, but yeah, indeed, we're not suggesting any changes to the design at this time that will compromise our delivery, and of course that will involve, a more involved stakeholder process, same introducing changes, tariff changes, and everything. So, at the potential, I'm saying potential because we may not even need to go. Future enhancement in EDAM, and we do have a quite long list of enhancements that we have for EDAM at some point, after some time when we get the experience and see how it's working, we'll be able to even formulate more accurately potential enhancements coming from stakeholders, from participants, from us, seeing how the market behaves. We already have a list, and we'll probably be, talking through some stakeholder process about enhancing EDAM, and this is one aspect of EDAM, the greenhouse gas model, and how you can make changes if there need to be made changes. We may find out from operating EDAM for a year, you see I'm mentioned there for a year, right?
Mhm.
That everything works so well, we don't have to touch anything. Would be a nice outcome. You know, if it's not broken away, you try to fix it. Or we may find out that, yes, we may need to make some enhancements that will be providing some better outcome. But I don't think at this point we have the benefit of having EDAM online to observe it and see how it works. And we all need to learn from it because it's new to all of us, right? So thinking prospectively, I would say reasonably, you need to collect the information and the experience for a year to see how it's working. And it will take at least that long to set up a thorough stakeholder process going through all the elements that we may want to change, along with tariff changes and everything. So it's certainly not for tomorrow.
Okay.
But that doesn't prevent us from talking about it and discussing and exchanging ideas of what can be. And
Got
that's
it.
why we're here.
Wonderful. Yeah, I was just trying to, yeah, get a sense of potential timelines if they were to occur. My role here in Department of Ecology, working on the cap and invest program for electricity is I'm relatively new to it, and I don't have a sense of overall CAISO timeline processes. And I will say that I think, you know, as just a department for Washington, we'd be deeply supportive of any options that reduce overall market cost and Washington cost. But I, I think my concerns that I raised earlier would remain, and there'd need a lot more discussion about how, like, we have an obligation to assess compliance obligations and covered emissions for imports into Washington. And that really relies on knowing what that import is. And right now that's done really with a first jurisdictional deliver approach and pointing to specific resources that in the market voluntarily opt in to serving Washington if they're in one of the centralized electricity markets. And so there's just a lot of fundamental things about this approach. There was a lot of talk about, just shift, the obligation to load within Washington. That's like a fundamental change to how we assess emissions associated with imports. And that would just be huge and is totally like not aligned with how we assess compliance obligations for in-state facilities. Like how we assess imports and how we assess in-state facilities are really wholly two separate mechanisms. And this doing a load-based approach would totally blur the lines there, and I don't even know how it'd work. So I just really encourage, as this goes on, to meet with CARB and Department of Ecology to just talk about the fundamental hurdles we would have with implementing this approach in a way that is fair and uses data. I don't think we want to be forced into, it would be really unfortunate if we were somehow forced into an outcome that said anything, any imports coming from the centralized electricity market have to be given an unspecified emissions factor because we just don't know what they are, and we don't have a good mechanism for accurately determining their covered emissions. So we're going to be conservative. That would be a really bad outcome, I think. And so, but I don't really see how this really works with our fundamental frameworks right now. So I just really encourage a lot of discussion and probably offline discussion with the regulators on if this is going to continue to be explored, how it could fit with our regulations.
Absolutely. And we do have an open dialogue with the regulators, and we work closely, all of them. So yes, this is not any solution. It won't be a solution behind doors here, definitely. but well spoken.
We just received one more question from Elisa.
Yes.
Hey, George. This is Alyssa K. with Bonneville Power Administration. Thanks so much for putting these slides together, and to the CAISO for your willingness to entertain thinking through these alternative options. I just really wanted to echo Callie's sentiments or request about including some thinking on secondary dispatch issues or impacts associated with these alternative scenarios, whether it's this one or further ones that the CAISO is exploring. And that cost is a component to be considered, certainly an important component, but that secondary dispatch component is important too. And ultimately, at least under CARB's program, has cost for ratepayers at the end of the day in California. So I'd encourage the CAISO to include that and not just look at the pure dollar implications of these different alternatives as well. Thank you.
Thank you.
And I'm not seeing any other questions at this moment. George, did you have any final thoughts before we move to the next section?
No, please go ahead. I'm done. Thank you. Thanks so much.
Thank you. I'll turn it over to Anya now to cover accounting and reporting approach.
All right, good afternoon, everyone, and thanks for joining this working group meeting. That was a really great discussion from George. Really appreciate folks' involvement. And now we're going to shift gears to talking about the accounting and reporting approach. Let's move to the next slide. So as part of this next section, I'm going to walk through some very high-level feedback on the accounting and reporting approach from our last meeting before talking about the issue paper that we published on the accounting and reporting approach last month on December 20th. And I'm hoping that this conversation can also recenter the group on what we're collectively trying to achieve with the accounting and reporting approach, some sharing of ideas on how to get there, and sharing some of the feedback that we've received from you all to date. I also want to flag that we'd like to adopt one of the stakeholder recommendations for a small group breakout session so that we can have a small group get together and co-develop maybe what this report would look like more in a template form and bring it to a future working group meeting. Isabella is going to cover this as part of the next steps after my overview, but in short, it's going to involve emailing me if you'd like to be a part of that subgroup. So with that, let's go ahead and dig into some of the feedback from November. Let's go to the next slide. So maybe as a reminder, the accounting and reporting approach is an out-of-market approach, but it's using both contractual information and market dispatch results to sum up what emissions an entity was responsible for. And after our last working group meeting, we had discussing the approach in November. We did ask stakeholders a variety of questions to narrow in on what stakeholders would find helpful with the report and to help us further refine the report options. So I'm going to review some of the themes of feedback here, but always appreciate folks chiming in terms of anything I may have missed or some nuance that you want to add to the discussion. So one of the first areas of feedback was, who is this report developed for? And the suggested report format that WPTF had put forward was that it would be at the LSE level based on the fact that state requirements are on the LSEs. I will note in prior working group meetings, CAISO had asked if a balancing authority area BAA level report would suffice, or if potentially using scheduling coordinator IDs could work to map those scheduling coordinator IDs to a kind of responsible entity, and if that would equate with an LSE level report. And we asked that because LSE information isn't information that the CAISO has today outside of some California-specific RA data. And so to produce this report in a least cost manner, we're interested in this SC mapping to a responsible entity equates with an LSC, and if that's a low cost, kind of faster option. And feedback that we heard from stakeholders was to focus on the LSC level report, but we didn't receive much input on scheduling coordinator mapping. So that is going to be in our next round of questions for you to answer. In terms of, working to understand, can you map your resources for generation and load to a responsible entity? And if that kind of gets us to this LSC level report. Another question that we asked previously that we're going to continue to drill into today and in the comment template and in future working group meetings is what data the CAISO should produce. We could produce the full report, which totals what a load serving entity dispatched based on their owned and contracted resources, net of what was attributed, because what's attributed is assumed to serve a GHG pricing region, and then net of their load, either adding in the megawatts from purchases or subtracting out the megawatts and emissions for what was sold to the market. Alternatively, the CAISO could produce just a residual rate, and stakeholders could use information they already have, like their own load data and what resources were attributed and their known information about contracts to formulate the rest of the report. And in that area, we didn't receive consensus on if the CAISO should produce a residual rate or the full report, and so we'll walk through that more in the coming slides. We also asked if contracts needed to be captured based on a longer or shorter planning horizon, and the feedback that we received indicated that capturing shorter term contracts might be necessary in the future, and there were some use cases where it was important. We also had questions around what data to use for load, whether that was based on a forecast of what load would be or actual metered load data. And most entities responded that using actuals for load data would be important. We also received feedback to develop an approach for non-participating resources and resources where emissions factor was unknown, and we'll talk about that in a later slide. And in response to feedback on the residual rate, we continued to hear from stakeholders that climate region would be beneficial, and that we should consider different approaches to a residual rate that considered kind of a new merit order based on either the economic stack or using gas first. And so that's something that we can explore in future meetings. And lastly, in response to suggestions that we had on potential replacements to the accounting and reporting approach, so locational emissions data or having a BAA level residual region with or without a climate region, we heard overwhelming feedback that these alternatives were not a replacement for the accounting and reporting approach. So really appreciate kind of the feedback received to date. And next I'm going to talk through the content of the issue paper. It is on our website. It was published December 20th. Let's go ahead and move to the next slide. And one more forward. So first, I thought it'd be helpful for us to ground ourselves in, some of the challenges. Why are we taking on this report? What are we hoping to solve? Just to make sure that as we dig into the details, we're staying aligned on those, and because these were raised in the issue paper. So one of the first challenges identified was that unspecified transfers might make it difficult for some LSCs to show progress towards state climate goals, especially for non-priced areas. And this is really driven by the fact that as a least cost security constrained market, there isn't a way to reflect a non-priced goal if there isn't a price and there isn't a constraint. It's also driven by the fact that the unspecified rate assigned to energy imbalance purchases from the market under state rules might not always accurately reflect the emissions profile of generation that serves an entity's load in every single interval. And lastly, there isn't a way for entities to limit the amount of megawatt hours of unspecified sources outside of forward contracting. That could result in self-scheduling, meaning they're bidding in as their generation as a price taker, and they might be going through that process of self-scheduling to make sure that the market dispatch supports compliance with their state's non-priced emissions targets. So we recognize there isn't a market mechanism today to make sure that an entity or LSE is only served by generation that doesn't exceed their emissions target. And lastly, there's a market challenge in that when you have an organized market, like the ISOs that's really looking at system energy, we're not able to track, and organized markets in general are not able to track green from brown electrons and their sources and sinks. And this is in contrast to bilateral markets where energy and the associated attributes are bought and sold by counterparties and can be tracked. Instead, with GHG design and EDAM and WEAM, we're really just looking to see if the dispatch resource receives an attribution to serve a GHG regulation area as a result of the bids that were voluntarily submitted. So we really see the accounting and reporting approach as one way to link the financial and legal arrangements associated with market dispatch. And that brings us to the problem statement that was edited by the working group, and we can go to the next slide for that. And really this problem statement centers around the market not having a mechanism that allows LSEs and energy users to account for energy and associated emissions used to serve load under either regulatory or voluntary greenhouse gas reduction and clean energy goals. And there were a host of sub-issues with this related to what generation serves load, tools for an LSE's portfolio to meet a target, and lastly, approaching these goals when there's both a price on carbon as well as kind of a emissions reduction target, since some states have both approaches. So let's go to the next slide. So in many of the sessions, I've used this formulation to summarize the accounting and reporting approach, but as a reminder, the objective is on a 5-minute basis for a state, load serving entity, or energy user, you're totaling what was dispatched by the market that was owned and contracted by this entity. You're netting out what's attributed, and then based on the load, there's an assessment if this entity was long or short. And if they were long, meaning they sold more than they consumed, you'd net back at their LSE rate. Whereas if they were short compared to their load, meaning they were a net buyer, you'd add in the megawatts and associated emissions at a residual rate. And there is a note for considerations for null power, recognizing that some states like Washington State have strict double counting provisions. And once we've received more information on how to account for null power, we could take various approaches. It could include approaches like producing one residual rate that excluded zero emitting power and one that did have zero emitting power in it. Or another approach could be just to produce the megawatts and associated emissions for each resource to allow entities to compile their own residual rates. So more to come in some of the details here. And next, let's move to the objectives. The issue paper outlines the objectives of the report, both as presented by WPTF and kind of further refined by stakeholders as really providing standardized tracking over time, providing a means to accurately assign energy and associated emissions, more precisely accounting for transfers to a non-greenhouse gas regulation area, since today's attribution mechanism really just looks and reports out on transfers into a GHG pricing regulation area. It also accommodates different approaches for accounting clean energy, considering there are different state and voluntary reporting approaches. And the last objective is not imposing on non-greenhouse gas regions. Next slide. So 2 key decision points I see our working group needing to answer before getting into another level of detail are really uncovering what data should the ISO produce to support this report, and what entity is the report developed for. And this has implications for kind of the subsequent questions and the level of kind of IT lift, and it impacts kind of the timing of being able to produce this report and the potential cost to stakeholders in developing the report. The next 2 slides are going to get into the data issue, but I'll spend a moment here on the entity question, which we talked a little bit about in the overview of stakeholder perspectives and the last comments that came in. We have heard clearly from stakeholders that while it might be helpful to have kind of an interim look at a BA kind of residual rate climate region, it's not a replacement. And this is really driven by the fact that climate regulations are largely placed on a load serving entity. However, we're still looking for feedback on what I'll call SC mapping as a viable approach. Again, this is because we don't collect information at the LSE level, largely outside of California RA data that we might collect. But our primary unit of measure is a scheduling coordinator for generation load bids. There isn't a one-to-one relationship with the scheduling coordinator in LSE, but a homework item for all of our working group participants is really to see if mapping and kind of providing the CAISO in the future an articulation of what are the load bids and the associated IDs from those load bids, as well as resources within your portfolio, is mapping that akin to the LSE approach. And we're asking that because it could be a lower cost option for implementation. So expect to see that in our comment report or comment template. With that, let's move to the next slide on just a decision point on what data the CAISO could produce. And I've highlighted this in the formula just to recap what we mean by, where the residual rate falls into the formula versus the total. But really, we're looking for more information from the working group on should the data the CAISO produces be this at the residual rate or for the report total. And let's go to the next slide for some of the pros and cons, and here maybe some reactions from stakeholders joining today's call. If the CAISO were to just produce the residual rate, we see some of the benefits of this approach is that it's a potential lower cost, could be produced faster. Entities should have the other information like load data or what resources were attributed. But as a con, these entities will need to kind of pair the residual rate they receive from the CAISO with their other information to produce the full report themselves. The other option is just for the CAISO to produce the report total, which is a pro in and of itself in that it's produced by the CAISO for entities. But some cons to consider is that it would be at a higher cost, a slower timeline, and there could be possible data gaps. And one example of that is today, the CAISO doesn't have LSE level load information, and we would need each responsible entity to let us know what load information was on a 5-minute basis. And in some cases with that volume of data mapping at a 5-minute level, there can be just gaps in that data. And maybe I'll just pause here to see if stakeholders have any other framing that they'd like to provide, any other considerations for the group, feedback or questions, noting that we don't have exact costs or timelines related to these various options at this point.
I'm not currently seeing any hands raised.
All right, well, let's go ahead and move to the next slide then. So this slide discusses an adaptation to the report that was introduced for feedback. And we heard from WPTF in terms of allowing GHG pricing areas, allowing those LSCs to share excess. An adaptation to that original proposal was brought forward by Portland to have more of a voluntary basis for a climate region. And there would be two ways that this could be effectuated. And we haven't shown it visually or in this formula until the issue paper. But it would essentially, when you're totaling what a resource or what an entity consumed from the market, kind of ahead of doing any assessment if they were long or short, you're allowing that voluntary climate region to allow those LSCs to share any excess megawatts and the associated emissions before doing that totaling of if they were long or short relative to their load. And then another element to that voluntary climate region would be allowing them to have a different residual rate, one for the voluntary climate region and one for the non-climate region. And this would allow an entity that's LSC that's in one of those voluntary climate regions to use the associated megawatts they're short for the first kind of tranche that they're short of before they would use the residual rate for the non-climate region. As noted in the issue paper and in previous working group meetings, the ISO would not be the decider of who is in or out of that climate region. If the CAISO is just producing a residual rate, and depending on how that is done, we may just need to produce the residual rate for each LSE, and then entities that are in that voluntary climate region could share information with each other on what, what their residual weights are that should be shared, versus if the CAISO is producing the full report, we would need to know from stakeholders who is in or out of that voluntary climate region. So wanted to formulate what that voluntary climate region, what the impacts would be to the report, both from sharing kind of what resources were long or short within that voluntary climate region, and also the impacts to the residual rate. In general, we've heard feedback that the notion of a voluntary climate region was acceptable, but maybe I'll open it up here if there's any other implications that should be considered. And I see Claire with her hand up. Go ahead, Claire.
You should be unmuted now, Claire.
Claire, your line is unmuted. You may be muted on your headset or your phone. Claire, I'm not getting any audio from your line. You may have to select a different microphone. You should see a way to switch audio under your audio settings, or you can send your question through the chat.
Back to you, Anya. We'll see if we get a question in from the chat.
All right. Well, I see Camille with her hand up.
Yeah.
Yeah.
Thanks, Anya. Department of Ecology is interested in this only really as an observer, since I don't think this really impacts our regulation directly. And as that, I'm just kind of asking for a clarifying question, asking a clarifying question for my own understanding. This approach, is this something that's only of interest for LSEs that are not within a GHG zone? Or is this accounting and reporting approach also of interest for LSEs who are in a GHG zone? And if so, I'm wondering if resources that are attributed to a GHG zone ends up as a plus sign anywhere in this approach for LSEs that are in a GHG zone, or do they just kind of disappear from this accounting and reporting approach completely?
Thanks, Camille. The idea behind the report is that entities are opting in and saying that they want the report produced. There has been interest from LSEs in pricing regions. And I think what's important to highlight about what is attributed is kind of the upper portion of the formula looks at netting out what was attributed. And that recognizes that if this entity is situated outside of a pricing region, there's a chance that one of its owned or contracted resources, if it's bidding in to serve load in California or Washington, could be attributed. It's netted out or subtracted out to reflect the fact that that dispatch and the associated emissions of that dispatch shouldn't be associated with their portfolio as it's serving California or Washington load. The same approach could be used for a LSE or entity in California or Washington if there is attribution, in an example where this is, produced for a Washington entity, any resources that are attributed to California would be subtracted out as well. I hope that helps, but happy to answer follow-up questions or if other stakeholders want to react to Camille's question.
Yeah, I think I understand that, like, a resource within, or an LSE who owns a resource within Washington that is attributed to California wouldn't get to count that, or would have to have it subtracted out. I guess what I'm just wondering is, there's a bunch of resources presumably that will be attributed to GHG zones. And I guess I was just wondering if those show up as a plus in any LSE calculation. Yeah.
Okay, I think I'm better understanding your question. Took a moment to sink in. I think the other element to consider is this does require entities to notify the CAISO about, what should be associated with essentially their entity. And so if you have, this kind of brings up a later question that we'll be getting to of what do you do with entities that aren't voluntarily participating in this? What assumptions do you make about who owns what? Because if you don't have that information, that energy and that associated emissions and the associated emissions, even if it's attributed, ends up in the residual rate. And so I think that it's a good question because it further highlights what assumptions should the CAISO make when it comes to non-participating entities and resources.
Thanks. Yeah, I need to tune into this discussion more, but that's helpful. Thank you.
Thanks, Camille. Claire, I see you're back.
Let's try this again. Can you hear me now?
Yes.
Excellent. Sorry about that. This is Claire Bridnich with the Western Power Trading Forum. And it's actually, I'm actually glad that Camille had raised her question first, because I think that's a good starting point for this issue of the inter-greenhouse gas area adjustment. And in my view, it seems to me that load serving entities in a greenhouse gas pricing zone may very well want to use this accounting mechanism. It may not necessarily be because of a mandatory state program. It may be for a voluntary greenhouse gas emission goal they've set for themselves. Or, we don't know what SB 100 is going to look like in terms of a long-term compliance framework in California, whether that will have any greenhouse gas component. But we know we already have SB 350 greenhouse gas planning targets in the IRP process. We know we have the power source disclosure. And I could imagine that a California utility might want to use an accounting approach to better align and facilitate those processes internally. So I don't think we should rule out the possibility that entities, load serving entities in a greenhouse gas pricing area might not want to use this sort of framework. That said, even though this is fundamentally a load-based accounting framework for the greenhouse gas pricing zones areas, I think we need to ensure that the way the accounting and reporting works aligns with how the deeming works. And so in the case that you have, for instance, an entity or two in California who elect to participate in the load-based accounting, to the extent that there is other energy available, if that entity is short, and to the extent that there is other energy available to serve that entity's load, either owned by resources, owned by other utilities within California or IPPs in California, or if it's an attribution of energy, a deeming of energy that it was not contracted to energy, that energy has to be considered to serve the load of any entity that's short, because that's where you're getting the energy supply and emissions into California, or conversely into Washington, if we're thinking about California. If we were instead to say, oh, when that entity is short, we need to look to the market residual, the broader market residual, then we've misaligned the accounting. And I don't think that is the intent. And I wanted to bring that up because I don't think it's voluntary. It doesn't mean that the entity has to report, but to the extent that there is accounting done for entities, load serving entities within a greenhouse gas pricing zone, then I do think that this intra-greenhouse gas area adjustment or attribution has to take place before you look to the broader market residual. So I would make a distinction between the inter-greenhouse gas area adjustment that needs to take place for the greenhouse gas pricing states to align the accounting and reporting with the deeming, versus the voluntary inter-greenhouse gas area adjustment that might occur because entities voluntarily get together and agree to set up arrangements among themselves to effectively share their clean energy or their length. And I just wanted to clarify that distinction because I think it's important. Thank you.
Thanks, Claire. And maybe I will take that comment as an action item to update this formula so that it shows kind of what would need to take place in a climate region versus voluntary climate region when it comes to the LSE adjustment, recognizing your comment of the need for that to occur in the pricing region versus the option for it to occur in the voluntary GHG pricing region, kind of the first part of this green equation. Thanks, Claire. Camille, I see your hand is still up. Did you want to respond, or did that raise any additional questions?
No, I meant to lower my hand, but I think Claire put into words like connections that I was struggling to verbalize. So thank you.
All right, I see Jonah's hand up. Could we go to Jonah next?
Yeah, hi, can you guys hear me?
Yes.
Wonderful. So Jonah Cabral here with Portland General Electric. Thank you, Anya, for walking us through all this stuff, and Claire as well for jumping in. I know that we've been heavily involved in all this whole learning process because obviously Portland General, we are in a non-priced state with pretty robust GHG emissions reductions requirements. So I know that we've talked a lot about the voluntary intra-GHG adjustment, and so just generally speaking, I guess for the benefit of everybody, and just to restate it, PGE, we're interested in this adjustment, or I guess rather the intra-GHG area, like adjustment for any excess in a given interval, again, because we think that there is an importance to states or entities like PGE that have a requirement to build out clean energy resources, but no price associated with it. So having a separate residual climate region type concept, again, it would just help kind of better reflect the value of those clean resources that such entities are by law required to bring on. So that is again just where we're coming from when we talk about the voluntary adjustment, understanding that it would be separate from the intra-GHG pricing zone, understanding that the shortfall of energy needs to be allocated within that zone prior to any other voluntary intra-GHG adjustments. So wanted to clarify that, and thank you, Anya, again for walking us through this.
Thanks, Jonah. It sounds like there's kind of alignment there between you and Claire on what it would mean for the GHG pricing regions versus voluntary pricing regions. So appreciate that back and forth and clarification, and we can make that update in our next round. I see Mary's hand is up. Go ahead, Mary.
Hi there, can you hear me?
Yes.
Okay, great. I think I just had a follow-up question, maybe for both Claire and the gentleman from PGE, who I missed his name. I think I have been thinking about the adjustment for non-GHG pricing zones more in the way Claire had talked about it, almost like a bilateral arrangement where entities can agree to participate in that. But I thought I heard something different from PGE, and I think my question is if it's an approach that, did I misunderstand that from either Claire or PGE? And if it's not the way Claire framed it, how do we sort of make criteria or have a judgment about sort of who gets to participate in the sort of clean sharing area versus the rest of the market?
Could we unmute Jonah's line?
Yeah, I think looks like I'm unmuted. So again, Mary, yeah, this is Jonah Cabral from Portland General. I think we understand that it would be very hard potentially. We've talked a lot with other entities as well to decide who would qualify for something that was more than a bilateral disagreement to share the excess. So I think we understand the challenges in that. I think that it's not necessarily something that is, well, we understand it to still be fluid and under discussion. But yeah, we do recognize the challenge of, figuring out, well, does this policy allow for somebody to be in a voluntary intra-GHG area? Does this one not? So to the extent that it would only work if it was a bilateral arrangement, that might be something to clarify. But whatever the shape did take, I think it would still, our intention is still to allow for the value of that incentive or requirement to build out clean to be shared among those participants who have to make those investments.
Okay, thank you for that clarification. That was helpful.
Appreciate that back and forth among our stakeholders. I think, you know, what I want to underscore here is the CAISO is not going to be the decider for kind of what entities are in that voluntary intra-GHG area, climate adjusted area, but looking forward to hearing further discussions on if outside of kind of a bilateral arrangement, if there's anything else that should be considered that needs to make its way into the report format. All right, well, let's go ahead and move to the next slide then. This other area related to contracts is under this general theme of obtaining information that the CAISO does not have access to today. And this area is really about who owns what and when. So for any owned contracts, this would appear in the resources owned and contracted, megawatts and emissions, anything uncontracted, or that the CAISO doesn't know is contracted with would be in the residual rate. And so a key question on contracts and building IT systems to support these contracts is knowing kind of what time frame of contracts to capture. A suggestion based on some of the collective feedback from stakeholders so far that we can work to refine in a smaller group is maybe taking a short-term approach with this first cut of the report of reflecting long-term contracts, and that maybe a longer-term approach could be to update these contracts to reflect day-ahead kind of shorter-term contracts if needed. So maybe I'll pause there and see if anyone wants to kind of share a little bit more about these short-term contracts, or if there are any reactions to this approach of, you know, reflecting long-term contracts as an interim approach before, you know, updating it to have shorter-term contracts in the future. And I'll wait to see if there's any hands that pop up.
Not seeing any hands coming in quite yet.
All right, and this will be another area where, you know, really to build this out and understand kind of what's in and out, understanding the nature of those contracts and understanding the temporal nature of how fast these transactions are occurring and what needs to be included in the report to be captured with that entity's emissions versus recognizing that if it's not associated, it will be just in the residual rate is going to be an important element of design. Let's go to the next slide. So this next area, I think, is going to raise kind of a good discussion, but it's really how to approach obtaining information for non-participating entities and for resources where we may not know the emissions factor. And, you know, a starting place for discussion for a non-participating entity that's not using the report or letting the CAISO know what resources are associated with it is to simply use kind of the information we have today, which would be the master file resources to assume contractual commitments. That does mean that, you know, any third-party generation would likely end up in the residual rate. So that's an area of feedback that I'd love to hear from the working group on, you know, other ways that we could think about either obtaining this information related to contractual commitments if there's an entity that's not planning on using the report to be able to kind of reflect ownership or not. And then there's kind of the question of for resources where we don't know the emissions factor. We've presented this in the past and largely heard support of this, although stakeholders did say that we would need to get feedback from state air regulators. I also heard WPTF in particular recommend eGrid data for consistency, but the kind of recommendation, if unknown, is, you know, obviously if it's submitted and we have that information in the master file, to use that, otherwise to use eGrid, otherwise EIA, and if that's not available, to be calculated by the CAISO based on the fuel type and heat rate. So maybe I'll just pause for a moment and see if there's any recommendations that stakeholders have really for this issue where if there's an entity that isn't planning on using the report, how to make assumptions about what's owned and contracted for. And I think this also goes back to Camille's earlier question on, if there's an entity that's not using this report and their emissions are attributed, how can that information be collected if the CAISO is not made aware of contractual commitments?
See a hand raised by Mary.
Oh, thanks, Anya. This is Mary Winkie from the Public Generating Pool. I am curious, do you, for owned resources or just for resources in general, does CAISO have the information about who is the owner of that asset, setting aside for a minute the question of contractual arrangements?
No, there's just an association to say, this resource is associated with this BAA for X period of time.
Okay, so you wouldn't have the information about which load serving entity within that BAA owns that resource.
Correct. And that's one of our kind of big implementation challenges, is not having the association of generating resource to LSE.
Okay. Okay, I want to think about this question a little bit more. I do think that just at a high level, right, I feel like it would be really challenging, right, for the collection of contractual information for entities who are, sort of opting out of participating in this. And I guess I think it may not be that much, it may not be a huge concern if there's sort of not perfect information about all contracts across the market that are reflected in this accounting approach. I am more concerned about, larger portfolios that are clearly, serving someone's native load, that then just gets sort of put into the residual mix just by default because of lack of information, which I think is kind of where you end up. Without more detailed information, you kind of have more of a quantity of resources and energy that gets put into the residual. So I think that's kind of the trade-off there. And I think I just want to think through kind of the approach on that, kind of given that the resources are essentially mapped to a BAA versus a load serving entity. But thanks for that, Anya.
Thanks, Mary. And I think you've kind of captured the challenge we're having well, in that, without that association to the LSE, how do we really know, what generation should be assigned where? And if it is not known, it does make its way into the residual rate. And there can be cases where, yes, it is assigned, but without the CAISO knowing, it would end up in that residual rate. Claire, I see your hands up.
Yeah, thanks, Anya. I echo Mary's concerns on this. I agree with Mary. I think we need to let the contractual commitments go for the non-participating resources. I just don't think we can get to them. That said, however, it does seem to me that we should be able to get to the owned resources. And even if you don't have that data is out there in all the myriad IRP filings that are out there for the utilities. I know that might cause the CAISO to pause, but I could see, for instance, that you could hire a consultant and have them map resources to LSEs. And then I think it's only problematic if there's no way for the non-participating utility to override it. And it seems to me if you did this initial mapping that identified resources throughout the West that are owned by LSEs and map them to those LSEs, and you have a way that an entity could step forward and go, oh no, we sold that, or no, this should be somewhere else, you've got coverage. So I think it's something we should explore, because I think it would be a big gap and really undermine the value of doing this sort of accounting if we can't at least get to the owned resources.
Thanks, Claire. Camille?
Yeah, I just had a question. What Claire said about mapping, using the IRPs and mapping resources is like a big part of my job, totally separate in the Capital Invest program, and I also would not wish that upon anyone. And that made me think, is there a way under this approach, the accounting and reporting approach, for one resource to be mapped to various LSCs? Because I know there are definitely resources that are, an LSC only has a percentage, owns only, or it has access to only a percentage of its output or something like that. And it's split up. And so like, is that enabled by this approach?
Thanks, Camille. I think the idea of needing to separate capacity, like recognizing that some units are capacity differentiated or time differentiated based on ownership, is something that the report is trying to capture, in that by capturing the temporal aspects of who owns what when, you could have a scenario where, one resource is owned by one entity for part of the year and not another, or one day and not another. Similarly, it's trying to pick up, capacity differentiation, recognizing some units are jointly owned, or, the capacity is sold to various off-takers. So there is a recognition of that. But this is a bigger challenge for us to think through in terms of how to do that mapping and maybe who the right entity to perform that mapping, or if there's a kind of single consolidated IRP database out there. So more to think through on that front, and welcome feedback in that area.
Yeah, I don't envy that work. Having tried to do a very simplified version of it.
All right, Mary or Claire, any follow-up to that discussion? I see both of your hands up. Maybe they're old hands. All right, not seeing any more hands. I'm gonna just move us maybe closer to some of the next steps. I think we've gotten into some of like the larger challenges where we are looking for feedback in order to implement this approach. Key of which is, what to do with the kind of non-participating entities and kind of contractual commitments to those entities. Let's go ahead and move to the next slide to just talk about a bigger timeline for the accounting and reporting approach. Largely we're hoping that, in the coming months, we're able to align and report attributes and the format of the report. And I'm hoping that a smaller working group session can help formulate that, and that a small group can kind of help piece that together and bring it back to this working group. So Isabel's going to talk about that next. And then, still open to providing interim BAA metrics to have a more precise unspecified transfer rate, if that would be helpful or of interest. And then really kind of looking at this accounting and reporting approach going live post EDAM go live, in terms of making it available for stakeholders. So hopefully this was a helpful kind of rundown of what is in that accounting and reporting issue paper, if you haven't read it already, and highlighting some of the challenges that we're really looking to co-develop solutions with you all on. With that, I'll turn things over to Isabella.
All right, thanks, Anya. Okay, so next steps. As Anya mentioned at the beginning of today's call, we will be hosting smaller sessions with stakeholders that plan to use the report to co-develop that format. So if you are interested in participating in those smaller session discussions, please reach out to Anya. Her email is listed here on this slide, agilbert@kaiso.com, so that we can mark you down as a participant in those sessions. As far as comments on the issue paper and today's working group discussion goes, Those will be due February 11th, so we will be posting the comments template out on the initiative webpage here this week, and you'll be able to submit those anytime between now and the 11th. And then our next working group meeting is tentatively scheduled for March 11th, so be sure to look out for the notice in the daily briefing confirming that working group date. So. And if you would like to present during the next working group, you can reach out to me. My email is also listed here on this slide. Again, inicosia@CAISO.com. All right, any last questions before we conclude today? All right, I'll turn it over to Christina for one last reminder.
Thanks, Isabella. I just have a quick announcement for insights into the ISO grid and market operations. Be on the lookout for our Energy Matters blog, or you can always subscribe. Here you can see some of our latest blog posts. And with that, we'd like to thank you so much for joining today's discussion. As a reminder, this meeting was recorded for informational and convenience purposes only. The video file will be posted on the initiative webpage. We thank you very much, and we hope you have a wonderful rest of your day. Thanks.